The first clean signal from Proxima Centauri arrived on Webb's mirror as a whisper, and within minutes the room went quiet in the wrong way. The infrared spectrum was supposed to be a milestone. It became a warning. The star that the public has been told is our nearest, most promising neighbor lit up Webb's detectors with a level of ultraviolet and X-ray violence that has no equivalent around our own sun. Then came the second signal. The atmospheric residue around Proxima b was not the calm signature of a sheltered world. It was the signature of a world being scoured. And then the third. The wider stellar neighborhood, resolved for the first time at that sensitivity, looked less like a garden of possibilities and more like a graveyard of stripped rock. Tonight, I want to walk you through what Webb actually saw and why it should bother you. Not because the astronomy is exotic, because the astronomy is honest and the public version has not been. Here is the reversal you need to sit with before we go anywhere else. For almost a decade, Proxima b has been marketed as the closest thing humanity has to a backup Earth. That framing has been printed, repeated, and softened until it became a comfortable belief. The James Webb Space Telescope was supposed to confirm the promise. Instead, its infrared eye did something the press releases have not caught up with yet. It measured the environment honestly. And the honest measurement rules out the version of habitability the public was sold. What Webb saw isn't a doorway. It's a warning label written in light. And the reason this matters isn't astronomy. It's what it forces us to admit about our own future. Before I take you deeper, tell me in the comments what time it is where you are and whether you have ever actually read a habitability paper past the abstract. Because the language inside those papers is not the language you were given. Not by the headlines, not by the science communicators, not even, sometimes, by the abstracts themselves. Let's begin with the version of this story you have already heard. In August 2016, the European Southern Observatory announced the discovery of a planet orbiting Proxima Centauri, the closest star to our Sun. The planet was rocky. It was roughly Earth mass. It sat, they said, inside the habitable zone. That last phrase did the heaviest lifting of the entire announcement. Because in every headline that followed, habitable zone quietly became habitable, and habitable quietly became Earth-like, and Earth-like quietly became backup plan. Each translation stripped a qualifier. Each qualifier that got stripped was doing enormous scientific work. The habitable zone is not a promise of life. It is not even a promise of an atmosphere. It is a purely orbital definition. It is the distance range at which liquid water could theoretically exist on a rocky surface, if that surface has an atmosphere, if that atmosphere has the right composition, if the star behaves gently, if the planet has a magnetic field, if the geological history cooperated. That is a lot of ifs, and every single one of those ifs is where Proxima b runs into trouble. The follow-up papers said so almost immediately. Rebus and colleagues working through 2016 and 2017 modeled the radiation environment and concluded that Proxima b has almost certainly lost most or all of its primordial atmosphere. Erapetian and his team, working on stellar wind erosion, reached a similar conclusion through a different door. The academic record has been walking away from the optimistic framing for nearly a decade. The public record has not. That gap between what the papers concluded and what the headlines said is the softest part of this entire story. And Webb just made the polite version impossible to keep. Because Webb's sensitivity is not a headline instrument. It is a measuring instrument. Niarspec and Miri do not care about the emotional arc of a press release. They record photons. They record what is there. And what is there, at this point in the data, is not a friendly signal. To understand what Webb saw, you have to understand what Proxima Centauri actually is. It is a red dwarf, an M-class star. And the marketing around M-dwarfs has been almost as misleading as the marketing around their planets. The public impression is that a red dwarf is a gentler sun, a smaller star, a cooler light, a calmer neighborhood. That impression is scientifically backward. M-dwarfs are not gentle. They are violent. Their interiors are fully convective, meaning the entire star churns like boiling water from core to surface. That churn tangles and snaps magnetic field lines constantly. And when those field lines snap, the star releases energy in explosive events that dwarf anything our Sun produces. In March 2016, astronomers watched Proxima Centauri release a single flare that increased its brightness by a factor of 68 in the ultraviolet in seconds. In 2019, another instrument caught an even larger one, more than 100 times more energetic than any flare the Sun has produced in the modern record. Let that number sit for a second. Not a slightly bigger version, 100 times bigger, and not once, as part of the star's normal weather. Think about that phrase, normal weather. On Earth, weather is what happens when the atmosphere shifts a few degrees. On Proxima, weather is what happens when the star itself detonates in ultraviolet. These are not the same word. The public has been using the same vocabulary for two utterly different physical regimes, and the vocabulary has been hiding the difference. Now translate that into meaning. A flare like the 2019 event would dump the energy equivalent of a Carrington-class event onto Proxima b in a matter of minutes. The Carrington event of 1859 knocked out telegraph lines across an Earth protected by a full magnetosphere and a thick atmosphere. Proxima b sits 20 times closer to its star than Earth sits to the Sun. It has no confirmed magnetosphere. And these flares are not rare. They are the normal weather. Imagine a sun that occasionally opens its mouth. And now imagine standing beneath it without a shield. That is what the habitable zone means around a red dwarf. It means you are close enough to the fire to feel it. Which brings us to the mechanism the public framing quietly ignores. The very trait that makes M-dwarfs attractive for habitability searches, that long lifespan and close orbital zone, is the same trait that makes surface life on their planets almost impossible. The mechanism keeping the planet warm is the same mechanism cooking whatever lives on it. And there is a deeper structural problem hidden inside that mechanism. To sit in the habitable zone of a red dwarf, a planet has to orbit very close. So close that gravitational tides lock it. One face is permanently pointed at the star. The other is permanently pointed away. This is not a small detail. Tidal locking almost certainly kills the dynamo effect that generates a global magnetic field, because the planet no longer rotates the way Earth rotates. Slow rotation means a weak or absent global field. Without that field, everything else falls apart. Because the magnetic field is not decoration. It is the shield. It is the reason our planet has an atmosphere at all. Here is the part that should bother you. On Earth, the magnetosphere is invisible. You have lived inside it every second of your life without noticing. It deflects the solar wind. It funnels charged particles toward the poles, where they burn off as auroras instead of stripping our air. It is the invisible ceiling everyone on this planet lives under, and almost nobody thinks about. Take that ceiling away, and the atmosphere becomes cargo the star is free to steal. This is not theoretical. We have watched it happen next door. Mars had an atmosphere. Mars had liquid water. Mars had a magnetic field. Then, roughly 4 billion years ago, the Martian dynamo faltered. The field weakened. The solar wind, mild by our Sun's standards, began peeling the Martian atmosphere off, molecule by molecule. NASA's MAVEN mission measured that ongoing loss directly. It is still happening at a slow trickle, 4 billion years later. And this is under a star that behaves calmly compared to Proxima Centauri. Now scale that forward. Modeling by Garifo and colleagues in 2016 and Erepetian in 2017 estimated that the stellar wind flux hitting Proxima b is somewhere between 1,000 and 2,000 times what Earth receives from the Sun. 2,000 times. Under those conditions, an atmosphere resembling Earth's would not last geological ages. It would not even last a fraction of one. To be fair, and I want to be fair here, this does not prove that no atmosphere at all survives on Proxima b. There are exotic scenarios in which a very dense atmosphere or a very young resupply mechanism, or an unusual magnetic configuration could offer some limited protection. I am not saying life is impossible in the Proxima system. I am not saying scientists are wrong to look. I am saying the surface life scenario, the version of the story you have been told, is much harder to defend than the public version admits. What Webb's early atmospheric hunt has shown, on Proxima b and on the TRAPPIST-1 rocky worlds, is consistent with the harsher interpretation. Once you understand what the shield does, you start to notice what happens where the shield isn't. Now let's break another comfortable assumption. Even if Proxima b were a paradise, we still could not get there. Because Proxima Centauri sits 4.24 light-years from Earth. That number sounds small. It is designed to sound small. In real distance, it is roughly 40 trillion kilometers. That is the distance from the Earth to the Sun, multiplied by 268,000. Let that comparison work on you for a moment. Voyager 1, the fastest human object ever to leave our solar system, is moving at about 17 kilometers per second. At that speed, Voyager would need roughly 75,000 years to reach Proxima. Every human generation that has ever lived, from the first cave paintings to your grandmother, stacked end to end, would still not fill that trip at chemical rocket speeds. 75,000 years is longer than the history of agriculture. It is longer than the existence of cities. It is longer than the written word, several times over. It is roughly the time between the last Neanderthals and now. That is the trip, at our best current speed, to the nearest star. And Voyager is not aimed at Proxima. Nothing we have ever launched is aimed at Proxima. So the real number, for a probe we have not built yet, on a rocket we have not designed yet, is even worse than that. There are theoretical designs that do better. The Breakthrough Starshot initiative has proposed accelerating gram-scale sails to 20% of the speed of light, using enormous ground-based lasers. At that velocity, the trip becomes about 20 years. Sounds better. Now hear the fine print. 20% of light speed is not a spacecraft speed. It is a physics regime. A single dust grain at that velocity carries the kinetic energy of a hand grenade. There is no known way to decelerate the probe at the far end, and nothing that gram scale can carry a human, or a life support system, or a return capability, or even a decent camera. The proposal is a photograph, not a mission. Chemical propulsion cannot do it. Ion propulsion cannot do it. Fusion propulsion, which does not yet exist as a working engine, would still require energy densities we have not learned to control. Antimatter propulsion, on paper, could do it if we could manufacture antimatter at rates trillions of times higher than we currently manage, and if we could store it, which we currently cannot. This is what scale rupture means. A trip to Mars is not a longer trip to the Moon. A trip to Proxima is not a longer trip to Mars. It is a categorically different problem. It is the problem our civilization has no working answer for. So even if Webb showed us paradise around Proxima, we could not get there. And Webb didn't show us paradise. Now let's put a body on the surface, just for a moment, just to feel it. Assume, generously, that Proxima b has an atmosphere and a magnetic field. Assume you can stand there. What happens to a human being? The first problem is the light. Because the planet is tidally locked, the star does not rise and does not set. It sits, permanently, in one place in the sky. If you are on the day side, the red disk is fixed above the horizon forever. If you are on the night side, you never see it at all. If you are on the terminator, the narrow ring between the two, one side of your body is warmer than the other, permanently. The wind at that boundary, driven by the temperature difference between hemispheres, blows at speeds that would tear conventional shelters apart. Research on tidally locked exoplanet climates has repeatedly identified terminator winds as one of the most hostile features of these worlds. Imagine trying to build a house on a fault line where the fault line is the atmosphere itself. The habitable strip on a tidally locked world is not a garden. It is a permanent hurricane belt with two dead zones on either side. And there is no season, no relief, no shift in weather. The pressure differential does not go away when you sleep. It is a fixed feature of the physics. This is not a place a body was ever designed to live. Then there is the radiation. The International Space Station orbits inside Earth's magnetic field, and its crews still absorb roughly 150 to 200 millisieverts across a 6-month rotation. NASA has historically capped career astronaut radiation exposure in the range of 600 to 1200 millisieverts, depending on age and sex. During a Proxima flare, unshielded surface exposure could exceed a full career limit in a matter of hours. Apollo crews spent days in cislunar space with careful shielding and still worried about a single unexpected solar event. Apollo 12 was struck by lightning on ascent and nearly lost. Apollo 13 nearly did not come home. Every one of those missions came within a razor's edge of failure inside our own magnetic shelter. Proxima B's surface during a normal flare week would exceed Apollo emergency thresholds in minutes, and there is no home to come back to. Then there is the circadian collapse. Human biology is tuned to a 24-hour rhythm that we did not choose. It was chosen for us by the rotation of this planet under this star. Antarctic winter over crews, ISS long-duration astronauts, and submarine crews have all shown that when that rhythm is broken, sleep architecture degrades, immune function drops, cognitive performance falls, and depression rates rise. On Proxima B, the rhythm is not broken. It is absent. There is no day. There is no night. There is only a red star nailed to the sky, or a permanent frozen darkness. No sunrise your body can anchor to. No sunset to tell you the day is closing. No moon. No shifting shadow. No seasonal light change. Your internal clock, tuned by 2 million years of evolution to a rotating planet under a yellow star, would drift and unravel. Within weeks, the crew's sleep would collapse. Within months, their cognition would. Habitable was always a planetary science word. It was never a biological word. And this is the part where you realize the biology problem isn't downstream of the engineering problem. It's the same problem. Now widen the frame. Forget standing on the surface. Forget propulsion. Just consider the communication architecture. Proxima Centauri is 4.24 light-years away, which means a radio signal from a crew on Proxima B would take 4.24 years to reach Earth. Any reply would take another 4.24 years to return. A single exchange, one question and one answer, takes 8.5 years. On Mars, the delay peaks at about 24 minutes, and NASA already builds enormous autonomy layers into its rovers because that delay is too long for real-time control. On Proxima, the delay is not too long. It is generational. Your emergency call reaches Earth after your grandchildren are born. Your mission's answer to a crisis arrives after the crisis has resolved, one way or another, without you. The Deep Space Network, which handles most communications with our robotic explorers beyond low Earth orbit, is already oversubscribed. Its largest antennas are 70 meters across, and the signal power falling on them from a Proxima probe would be measured in fractions of an attowatt. There is no architecture in any real agency roadmap that supports crude communication at that scale. There is no resupply architecture either. The ISS is resupplied roughly every 2 to 3 months. That cadence has failed on multiple occasions, and each failure has forced schedule adjustments and rationing. And the ISS orbits 400 kilometers above our heads. A Proxima mission is not resupplied. Not in years. Not in decades. Not ever, on any current design. Apollo 13's rescue window was measured in hours, and it worked because the crew was still inside the Earth-Moon system. A Proxima crew would have no rescue window at all. No emergency return. No supply drop. No signal fast enough to matter. Consider what that means practically. When something breaks on the ISS, and things break constantly, a replacement part is on a cargo vehicle within weeks. When something broke on Apollo 13, mission control on Earth was awake and improvising in real time. When something breaks on a Proxima mission, the crew is alone with whatever they brought, whatever they can print, whatever they can salvage, and whatever they cannot fix, they die from. Isolation stops being a mission hazard. It becomes the entire mission environment. It is the wall the mission is built inside. So the question stops being when do we go and becomes something no agency wants to say into a microphone, which is that with current physics, current biology, and current engineering, we cannot go. Not now. Not soon. Possibly not ever in a form that resembles the crude exploration we have imagined since the 1960s. This is where we have to talk about the softening. Because if the physical evidence is this hard, why is the public tone still this soft? It is not a conspiracy. It is an incentive structure. Astrobiology funding at NASA and other agencies is defended, in budget documents, by the language of habitability and the promise of finding life. The word potentially appears in exoplanet press releases with a frequency that no one has quite catalogued, but everyone in the field has noticed. Original technical papers describe Proxima b as a rocky planet in the temperate zone of its host star, exposed to intense stellar activity with unresolved questions about atmospheric retention. The press releases that describe those same papers use the word Earth-like. That is not a translation. That is a rewrite. And the rewrite happens at the exact place where the public forms its beliefs. Most people never read a paper. Most people read a headline, a summary, a social post, or a documentary voiceover based on a summary of a headline. Every layer in that chain has its own incentive to sound optimistic. The paper says exposed to intense stellar activity. The press office says potentially habitable. The news outlet says Earth's twin. The social post says we found another Earth. And by the time it reaches the viewer, the word potentially has vanished. The word intense has vanished. The word exposed has vanished. And what remains is a promise the physical evidence never made. I want to be careful here. I am not accusing scientists of dishonesty. The researchers doing the work have been clear in their journals. I am accusing the communication pipeline, the interface between the paper and the public, of systematic softening. It is a pipeline that rewards optimism, because optimism drives attention, and attention drives budgets, and budgets drive careers. The optimism is not a scientific consensus. It is a communication strategy. And the viewer who has been told for a decade that we keep finding other Earths, and never told what the follow-up papers concluded, is not being lied to. He is being managed, which raises a harder question. If the nearest promising planet is this compromised, what does that say about all the others? This is the part of the story that stops being about Proxima. Because Proxima Centauri is not an outlier. It is representative. Roughly 3 out of every 4 stars in the Milky Way are M-dwarfs. That statistic has been used for years as a reason for optimism about habitable worlds. If most stars are M-dwarfs, and most M-dwarfs have planets, and many of those planets sit in their star's habitable zone, then habitable worlds must be common. That is the argument. Webb is quietly dismantling it. In 2023, JEWST observations of TRAPPIST-1b, the innermost planet of the most famous M-dwarf system in our sky, found no evidence of a thick atmosphere. Follow-up observations of TRAPPIST-1c reached the same conclusion. GJ-486b, another prime rocky planet target, produced water vapor signals that turned out to be ambiguous between a planetary atmosphere and stellar contamination. LHS-3844b, examined earlier by Spitzer and reinforced by later work, showed a bare rock signature consistent with no atmosphere at all. Every high-profile M-dwarf rocky planet that Webb has looked at carefully has come back with the same failure mode. Now think about what that means. Every past habitable candidate that got serious follow-up has been quietly downgraded. The list is not growing. It is shrinking. The optimism curve of the last 20 years, the sense that we were on the verge of a discovery, was drawn on a data set we did not yet have. Now we have some of that data, and the curve is bending the other way. If M-dwarf worlds are systematically failing to hold atmospheres, and sun-like stars are relatively rare and their planets harder to characterize, then the density of viable planets in the galaxy may be far lower than a generation of science communication implied. The Fermi paradox, The question of why the sky is silent may not require exotic filters or dark forests or civilizational suicides. It may just require the honest answer that habitability is harder than we let ourselves believe. That the tiny green windows we imagined were not tiny. They were vanishing. The Drake equation, the famous back-of-envelope calculation of how many communicating civilizations might share our galaxy, is only as optimistic as the numbers you plug into it. For decades we plugged in generous ones. The fraction of stars with planets. Optimistic. The fraction of those planets in the habitable zone. Optimistic. The fraction with atmospheres. Optimistic. Every one of those numbers is being revised downward as the actual data comes in. And the biggest revision is the one Webb is delivering right now. Which brings us to the part of this that isn't about Proxima anymore. It's about us. Let me consolidate what Webb has shown, and what the surrounding evidence confirms. Stellar violence around Proxima Centauri is not a possibility. It is measured. Magnetic shielding on Proxima b is not present in any evidence we have. Atmospheric persistence under the flux the planet endures is unlikely to negligible on geological timescales. The distance to the system is unbridgeable with current or near-future propulsion, and the propulsion required is not being funded at any level that suggests seriousness. The biological fit of a human body to that environment is catastrophic across radiation, circadian, thermal, and atmospheric axes simultaneously. The communication and resupply architecture required to support a crewed presence does not exist and is not on any real roadmap. The institutional framing around this story has been softened at every stage between the journal and the audience. And the galactic pattern, as Webb keeps looking, is consistent. This is not one bad planet. It is a signal about a class of worlds. And it is a signal about the class of world we were counting on to be common. Now return with me to that first image. The one Webb resolved on its mirror, the one that started this. That light traveled 4.24 years across a vacuum most human minds cannot picture. And it landed on a mirror the size of a small building. And it told us something. It told us that the planet we were sold as our nearest hope is not a hope. It is a warning. And it told us, by implication, that the sky is not the vast catalogue of options we let ourselves imagine. It is smaller than that, much smaller. Earth is not one option among many. On current evidence, Earth is the option. Not one of many doors. One door. The one you are standing behind right now. And every generation that has come before you has assumed quietly that if this one closed, there would be another. That assumption has been the emotional foundation of our relationship with the planet for a long time. Webb just knocked the foundation out. This is the point where a story like this is supposed to give you a way out. A frontier, a backup, a next step. I am not going to. Because there isn't one on any time scale that matters to the people alive today, or to their children, or to their children's children. What there is instead is an assignment. If there is no backup, then the systems keeping this one habitable, the atmosphere we take for granted, the magnetosphere we do not think about, the climate we treat as inconvenience, the oceans we treat as infinite, the soil we treat as forever, become the most important engineering problem of the century. Not because they are noble, because they are all we have. The stars are not hostile. They are indifferent. The shelter we already have is the one we have been treating as disposable. That is what Webb wrote in infrared. That is the sentence hidden inside the milestone. And that is the sentence I want you to carry out of this video, because once you have read it, you cannot unread it. We are not looking for a second home. We are standing on the only one. And the light Webb collected, 4¼ years old by the time it reached us, was not an invitation. It was a message. The message was simple. There is no next. There is only here. Act like it.